Today what we're going to be talking about is multi-fan blower door testing. I'm not going to cover a whole lot on building science principles. We have some other materials that you can find for free on our YouTube channel on that. So today what we're really going to go through is just kind of the basic mechanics of how to set up your fans, how to set up your gauges, and how to use the FanTestic software to get the readings that you need. So whenever you're testing large leaky buildings, a lot of the times one fan just won't cut it. So you just need some extra power there just to be able to get that accurate reading that you need. You have some options with the Retrotec equipment and how you can install fans in a doorway. So especially for commercial, you might have some large door openings, or you might have some loading bay doors that you can use. Some other roll top doors that you can use too. Sometimes if you have those double doors that don't have a post in the middle, frame and canvas may not be ideal. So we have some other options here. So these two fans that you see set up, these are installed in what's called our stacking panels. That's what these red squares are. And you can do a couple of different things with these. What I have done here is I've just taken a sheet of plywood and cut a hole so I can just screw this panel into it, and just stacking one on top of the other. If you have taller doorways, you can do 3. You can also use 2x4s or 2x6 framing to build your own little frame for this if you want to. We've seen a lot of customers do that. The largest thing I've done with these is fill up a loading bay door, so you can kind of get creative and just build the panel that you need to get this to work. And it just kind of keeps everything stacked and organized. Gets a nice tight seal against whatever it is that you're attaching it to. And what we usually see, let's see, yeah, you guys can see this. These clamps here, these quick grip things are great. That way you can cut out a little notch here, have these in, tighten it down, and it gives it a really nice grip into that doorway there, because with these high powered fans that can do 7,000-8,000 CFM, you're going to want to make sure that thing's nice and secure. But you can also do the classic frame and canvas too. We make different ones here. So if you have 2 fans, you can absolutely set that up in a doorway. We also have a 3 fan. So if you have an 8-foot doorway or taller, then yeah, you can absolutely use the frame and canvas also. So you've got some options on how you can do that, just whatever makes the most sense for whatever project that you're working on, or whatever your personal preference is. So one may make more sense than the other, just depending on what you're doing. But as far as getting the fans connected, what I have here, these fans look identical, but they're 2 different models. This is our model 5000 that's traditionally used in residential construction. This is our model 6000. This is our high output fan. This one will do about 2,000 CFM more than this one will. And you can see here at the bottom of the screen, it's got its own variable speed drive that sits separately by it that all the data cables will plug into. So that's one of the biggest difference between those. So it just has a lot more power. Ideal for commercial testing. That way you don't need as many fans. So you can get in and out of there faster, less equipment to work with. But the way you set these up, I'm going to switch cameras here on you so you can get a closer look at how this is all connected. There we go. You can see here at the top of this fan, I've got 2 data cables sticking out here. If you're familiar with our equipment, you've probably noticed this. There's an in port and an out port. And the way you have this set up, you have a gauge per fan. And the first gauge on the line is what's going to be called the dominant gauge. That's going to be the cook in the kitchen that's telling everybody else what to do. The rest of the gauges are just kind of there collecting data. That first gauge on the line is your dominant gauge that's telling everything what to do. So if you can see here, and you always want to make sure you have your manometers just kind of out of the flow of the fan so they're not screwing up any of those pressure readings there. But notice how this is the dominant gauge. It's called a master-slave relationship. So if you see it in the software, this will be the dominant, this will be the slave. You have a data cable coming out of this dominant gauge that then goes to the in port of the fan. So that in is that signal coming in from the dominant gauge. And then on the out port, we have just another Cat5 Ethernet cable that's coming out and repeating that signal to the next fan in line. So this 5,000 is first in line, the 6,000 is second. So you can see that data cable is coming into the drive on the 6,000 here. And then nothing's coming out because we're only using 2 fans today. So this is where the line stops. If we had more, then I would have one coming out to the next fan. And so you can kind of keep on going. The most fans I've ever done this with is 33. There's been tests that have been done with more fans. So you can test a building of any size. You just have to have enough time, equipment, and people to do it. So that's just what we call daisy chaining the equipment together. And again, those gauges are just going to be there. That first one's the control. This one's just along for the ride. What this does is, I'll switch cameras back here again. This allows us to keep all the fans running at the same rate at the same time. And that's really important. It's what we call common control. And we want that so that the fans don't fight each other. If they're controlled independently, so if we just had a gauge per fan and all those gauges are in control, basically what we have is too many cooks in the kitchen. And we can get fans fighting each other, especially if they are installed on other ends of the building. Then we can get some funky things going on. And there wouldn't really be a good way to know it unless maybe we took a thermal camera and looked at the fan motors to see them at different temperatures. So that's why we want, when we're doing a whole building test like this, we want to do what's called that common control test. That way, everybody's on the same page. All the equipment's doing the same thing. So that it makes it a whole lot easier to get those accurate results. Really the only time where we would want to use that individual style control is maybe if we're testing a multifamily building and doing a guarded or neutralization test where we have fans set up in several units, but we only care about the flow in one, and we're just trying to neutralize the pressure against those common walls. That's really the only time we would use that individual control, where we might be bringing several units under pressure, but we only care about the flow on one. So, but when we're doing large buildings, large leaky buildings like this, it's always going to be common control. So another thing here that's important to mention is getting that signal to your laptop. I always recommend using software. It just makes life easier. You don't have to do any additional math. It's going to take a series of readings, average them together over a set period of time, and just give you a more accurate result. Let's go back here and let me show you. Let's see here. Looks like my controls are lagging here a little bit. There we go. Out of these manometers here, you'll notice that I have 2 Ethernet cables coming out that are going into a router. And then this black cable is going to my PC. You don't always have to use a router. You can use an Ethernet hub. So it's basically a bigger box that just allows you to input a bunch on one end and output one back to the laptop. But here, just one router for 2 fans will work just fine. You can also, it's possible to connect these using the USB, but that Ethernet is going to be a more stable signal that'll give you less trouble, especially as you add more gauges in. And I'll pull up the software here in just a second to show you how that looks. So
hey,
getting
Sam,
those
you have time for a quick question?
Yeah, sure. Let me switch this camera back over. Go for it.
Barb was asking, is there a limit to how far apart the fans can be for this testing method? Like if you're at opposite ends of the building, do you need longer cables, or is there a different method to connect them up?
Yeah, so for those long distances, you definitely want to use that Ethernet connection. And I believe, Lee, you might know this better than I do, but I think you can have 300 feet
Yeah, it's
of Ethernet cable.
yep, that's correct.
Yeah, so I mean that gives you 300 feet of span right there, and you can use repeaters too if you need to. I've seen some customers do that to get some more out of it, just to repeat that signal down the line. But yeah, using that Ethernet connection is going to be your best bet for long distances. I've tested a building that was 1,000,000 square feet conditioned floor area. It took up a whole block in New York City. It was 13 stories high. And we did that exact same thing. So if you get into that scenario, just make sure you have plenty of Ethernet cables on you and tubing as well. You're going to have to run tubing. I know traditionally we like to keep tubing, under 100 feet, but I've done 300 feet and we were able to get good, clean, reliable data with that. But that's stuff that you'll be able to see in the software whenever you run those initial tests before to make sure that everything's cooperating the way it should. The software will tell you if something funky's going on. But yeah, just make sure you have plenty of both cable and tubing to be able to reach those long spans that you need. Because sometimes you need to do that. If you're doing a whole building test, sometimes you want to have fans on the bottom and up on the top to make sure that you're getting that building under an equal pressure all across. So that's where you got to kind of really look to see how that building's put together, to drop cables and tubing down stairwells, maybe drop them down elevator shafts to find that shortest path.
Yep. And then just to add a quick note there, you mentioned repeaters, and that's just referring to network switches. Network switches are your glue that you can connect up all your DM32s, your gauges together with, and then those go back to a router, which handles all the addressing and communication.
Yep.
So if you need to go beyond 300 feet, you can throw a switch in there, and then you can do another 300 feet with another cable if you needed to.
Yeah. But yeah, a good rule of thumb is just to try to keep sometimes it's hard to avoid, but it's good to keep it as short as you possibly can. That's what it's good to study that building just to find that shortest path. Whether you're going, horizontally or vertically, just see how you can cut through to try to avoid some of those issues. So yeah, I mentioned using software. You can also do this manually. So if you just have two fans and you're just shooting for a single point test, sure, you can get let's say we're doing a residential and we'll get the house under 50 pascals. You can just add your flows, the two DM32s together, and that's what it's going to be. But of course, if you use software, it's going to be a little more accurate. It's going to take those averages across a certain amount of time and do the math for you. But it is possible to do that. But usually we only recommend doing that in a pinch if if you don't have your laptop on you or something like that. But you can get that reading without it. But the more gauges you have hooked up, the less accurate it's going to be if you don't use that software. So one question that we get a lot is how do I know how many fans I need? And we have a tool for that. Let me share my screen right quick. Share. If you go to our website, if you go under software, under software and then tester tools, you'll see our number of fans calculator. And it's a calculator that we built in Excel. And you can put in some inputs about the building. You can choose whether if you're going to do the length, width, or height, or the condition volume, if ACH is what you care about, or you can enter in the envelope area, tell it the building height, the number of floors. Your inputs are going to be in blue, the results are going to be in green. So we have some of the basic standards here. So Army Corps of Engineers, LEED, Passive House, ATMA, they're all in here. But you can customize it too. So if you're looking for a certain ACH 50 target, you can add that. Same for just your raw or your CFM per square foot of envelope area. You can put that in too. And it'll tell you how many fans you need, whether if it's our standard power 5,000 fan, or if it's our high power 6,000 fan, or our older models too, like the 1 or 2,000 is going to be a standard power. Our 3,000 models, a high powered fan also. The flows on those models are roughly the same. So this gives us the maximum CFM that it's working off of. And these are pretty conservative. You'll notice that they're a little lower than what they're spec'd out to be. And this is to account for back pressure that you would typically be coming across when testing a building. And a good rule of thumb here is it's always better to overshoot than undershoot. Obviously, if you don't have enough fans, then you may not be able to reach that pressure, that maximum pressure target. But if you have, if you overshoot it, it's okay. You can either leave some out or just choke the fans down to a smaller range. But this is free. You can just download it off our website. And if you get a big project and just want to see how many fans, this is how you determine that. So I'm going to switch over to show you what the software looks like now. We'll start at the beginning and work our way down. If you have, basically what you have here is a series of drop boxes for different stages of the test. So we're going to do just a sample of a E779 multi-point test. So it lets you know that. You can also do duct testing in here. You can do residential duct testing. You can do commercial duct testing. So you have some different options of the kind of test that you can do in FanTestic. There's some different licenses. So I think if you just buy one blower door, it comes with FanTestic Lite, which will run one fan. But we have different levels of licensing for this, depending on how many fans you need to run. So you can reach out to us later about that, depending on what level of license you need to run it. The equipment, it can find the gauges. So just to make sure that we're all connected, it'll search for those DM32s that are plugged up and have our serial numbers here and all that, which fans that they're connected to. So you can adjust that as well. If you have all the serial numbers for all your equipment, you can pull the calibration information. If you're connected to the internet, it'll just pull it straight from Retrotec's database. So if you are working with a building official or someone that wants to see that, you'll be able to pull that from the software here. And of course, you can add additional notes like, where's the test set up? Where do you have these fans located? If you run a bunch of tests and you want to generate a test number, you can assign it there too. And then of course, some information about the building, any kind of description you want to have, the building address, any other details. The elevation above sea level. I'm on the coast here in North Carolina, so not very high up. And the building height, the volume, floor area, enclosure area, all that's really important to see if you're meeting a certain air tightness standard or not. So you want to have all that information, either from the plans or measured from on site, so the software can spit that out for you. If you guys have ever used rCloud before, that's our automated testing app for single fan tests. A lot of HERS raters use it, energy auditors use it, HVAC contractors use it. This software is basically that on steroids. It's a whole lot more customizable. You can add more fans, add more gauges, have some more testing options and things like that. And then we get into the actual test here. So we have our date, our start time, where we are located. So most cases, whenever we do these kinds of whole building tests, we're going to have everything set up on the inside. We're going to be on the inside. But there might be some weird scenarios where the user is on the outside, which is actually what we're doing today. We're testing this test chamber in here, but just so I can be spread out and you guys can see everything, I have everything here on the outside. So I'm going to let it know that. But if I wanted to change it to inside, I could, to let it know if we're doing a depressurization or pressurization test. And then, of course, your temperatures are important, especially if you get into more extreme temperatures. Like if you get into, if it's really cold, that's going to affect your reading. So you want to make sure you have all that put in here correctly too, as well as the wind. It's good to log that information. So you have some options on how you can enter this data. You can enter it manually. So if you don't have the software on you, but you want to use it, you can actually run these tests to whatever pressures that you want to, manually record them, and then enter it in later. A lot of people don't do that. I mean, if you can have your laptop on you, that's a lot better. But what a lot of people do with that manual is just kind of see what would happen in certain hypothetical situations. So you can input data, different pressures, and just kind of see what would happen in that building. Before you get out there. It kind of helps you get or maybe if you tighten the building up a certain amount, if you get lower, how tight does it have to get for, to reach, a certain amount of fans or whatever. You can play around with it like that too. But what most people do is either use the auto test or the semi-automatic test. I'm going to do a semi-auto test today. The difference between the two, if I do an auto test, once I hit begin, it'll take how many baselines I tell it to test, and it'll just run everything nonstop straight from there. If I do semi-auto, I kind of have more control. I tell it I'm basically telling it what to do as I go instead of me giving it a bunch of commands all at once, and it takes it from there. So some people like to do the semi-auto instead, just so they can, kind of adjust things as they need to. And the way that you do that, if you go into settings and advanced under this middle settings tab, that's when you tell the software, whether if you're doing a residential or commercial test. So that reference pressure would need to be 50 for residential, 75 for commercial. You can tell it how many baselines you want to take. So just for the sake of time, we're just going to do one. And how many seconds you want it to record. For windier days, you might want to bump this up a little bit higher than 20. And then as we do our induced pressures, since we're going to do a residential test today, I'm just going to start it at 60. We'll take 6 points. So we'll go down in increments of 10 pascals. And it's going to record those readings for 20 seconds each. And you can also reset all these to standard defaults too. If you ever kind of get into some funky stuff and can't remember what it's supposed to be, you can always hit reset. But these are the errors that it usually comes in. Must be less than 5% or 1 Pascal. So we're going to leave this as it is. And I see my gauges here as they're connected to fans. I can see what ranges that I'm set to. So I can adjust that here. So I'm going to go ahead and begin a semi-auto test. And it's just going to make sure that those gauges are still connected before it starts running anything. And then you'll see this window here pop open. And so the first thing that I want to do is take my baseline reading. And I'll see there's this data to collect window. And I'll just hit initial baseline. And you have to put a fan speed in. So I'm just going to put 0. And then you'll run the fans at that new target and then collect data point. And if I slide this over, this window is really important to pay attention to. So it's reached, it's not doing anything. So it's just collecting that data, seeing what those wind conditions are. And to take my baseline, I have 2 options. I can either use these shower cap covers, or I can just have all the plugs in my B8 plate. Either one works fine. And now it's gotten to that 20-second mark. So I can just hit, well, it's collected it there. I see it in the initial baseline. So now I'm going to remove that 0. And then now I'm going to do building pressurization flow. And my first target is going to be at 60. Now I'm going to remove these. I've already tested this chamber at the current leakage I've set it to. So I know I need to start at B8 on both. So kind of cheating a little bit. But usually what you would do is start with the fans open if it's going to be a large enough building, and see if you need to work your way down. And so I will run the fans with this new target. And so I can see that this box is yellow. And whenever it turns green, that means that pressure's been attained. Now I can start collecting data at that pressure target. Tell it okay. It's going to wait for it to stabilize. Now it's going to start collecting. So we've set it to collect over 20 seconds. It's going to take an average over that time. So we can see it's about halfway there, and we can see everything being recorded here for this first point. There, that's been collected. So within this semi-auto, I can stop the fans if I want to. If I need to go make some adjustments to something, I can. It gives me a little bit more freedom of what to do with my time. if someone needs to open a door and go out or whatever, they can do that and then shut it back, and then I can continue. That's the thing about the auto. You don't really have that break. It's just going to start at 60 and then work its way down and tell you when it needs to change ranges. But with the semi-auto, like I said, it gives you a little bit more control over the test. So I'm just telling it what to do as I go. So 50 is going to be next, and then I can hit run fans with the new target. There's also a little slide drawer over here that I can open up that'll show me the building pressure. So we've reached that 50, it's been attained. I'm going to collect that data point. Okay. And then I can see what each gauge is doing. So I can switch, see what their flows are, to see what's going on with each gauge. That way, if I suspect that something funky is going on with one of the gauges, instead of having to stop and get up and go look at it, I can just look at each one of them individually from here. So that one's been completed. I see it recorded there. And we can just go on down to 40. And I don't have to stop. I can just say run with new target and listen to it drop. And this screen right here is, it's saying low pressure, so it's time to go down. So I'm going to change everything. This is how I change my ranges. So the next one down is going to be B4. And an important thing to mention here, you want to keep all the B8 plates and the plugs together with the appropriate fan. If I pull this plate off, I can find a label that has a serial number on it. And I want to always make sure that matches the serial number on the fan. Same thing with the range plugs. That same label, that same serial number is on each range plug. And you always want to keep those together. And the main reason is because this is the plate and the plugs that the fan was calibrated with as it came out of the factory. Looks like I grabbed an extra one there. And then I'm going to do the same thing for the Model 6000. So whenever I stack these plugs to the side, I always want to try to keep them together. That way I know they all go to the same fan. So now we'll hit continue. We can hear those fans ramp back up. You can see it's almost to 40. There, now it's attained it. It's turned green. Now we can tell it to collect data. And you can see I've got a new row started for the new range. So we went from B8 to B4. So every time I change ranges, it'll start a new row and keep it going across. Cool. So now we'll drop it down to 30. Listen to it drop. We can watch it drop over here in this window. We can see that we haven't quite gotten there yet. Now we have. We'll go ahead and collect that data point. "20 seconds is typically the norm for most standards. If you hit default, if you're doing an auto test and you hit default in the settings, that's what it's going to go to. I can just drop it down to 20, run it with that target. And if something weird were to happen, let's say maybe somebody opens a door or somebody steps on a tube, or maybe the fan pressure was too low, but it didn't trigger a warning to change ranges, one of these cells would turn red. So if you ever get any data that turns red in any of these cells, that means you want to go back, you want to take that point again. And you can do that by, you can clear a point. Whenever it's not running, if you finish the test, you can clear a point, a window will pop up. You can choose which one of these pressure targets is red, clear it out, and retake it. So that way you don't have to go back and do the whole test over again. So this one's been attained. We'll collect it. Another problem that we get that we can run into in large buildings is bottlenecking, where maybe you don't have all that much space to connect back to the main space of the building. Like if you have it maybe set up in a room or a lobby and there's only one doorway to get through, you might want to find a new place to set up a fan or maybe run a reference pressure tube inside if you get some funky red readings like that. So it can mean a number of things. And if you get one of those, usually it'll tell you what triggered it, and that'll give you an idea of what to go adjust. And we've got one more here. We'll run it at that target. And you can see here which gauge is the primary gauge, which one's in charge. It's that first one on the line here telling the rest what to do. We can watch that error drop, and now it's attained, and we can just go ahead and collect that data point. And when we use FanTestic, there's actually two baselines that we take. It's going to take a pre-test and then a post-test. So we're going to do one more baseline after this test. So that data point is completed. It's recorded. So we're going to hit stop fans. And there's our data there. Oh, we actually need to do, since we're doing a semi-auto, we need to tell it to do that post baseline. Let's see. Put that over. Make sure this one's covered good. That final bias pressure, again, we'll just pop a 0 in there. Let it do its thing. And that's where that will generate there. So if there's a difference in the wind affecting the test outside between before we start the test and when we end it, it'll take that into account. And there we go. Now that it's all finished, I can hit calculate, and it has all my readings here. And then to see the results, and scroll down, and I can see what my flow is for envelope area. So 0.05. This is a really small chamber. I told it it's a very big building, so we got a low leakage rate there. So we put in some fictional information about the building when we went to the building details here. So I told it was a pretty good sized building. So we just put in that fake info there, and so that's where all of our information is there. What that raw CFM50 number is right here. It's about a little over 2,300, and so basically anything that we need to know to report is going to be there. And let's see. So I can generate a report off of this, and it spits it out in a Word doc. And that way you can, let's see here. That way you can customize it. So you can put your company logo on there. Oh, let's go back to that. So you can insert your company logo, customize it however you want to, but it has all of that information in there about how the building was performing. And in the Word doc, you can add whatever notes that you want, add any other photos that you want. So it just makes it more customizable that way. But that's a quick and dirty rundown on using FanTestic to do a whole building test with multiple fans. We do the best we can to provide any warnings if something's going wrong. Again, always pay attention to these numbers here. If any of them turn red, hover over it and let it tell you why. And that can give you some places to look, to change, to make sure that you get everything running correctly. If you want to dive into this a little more, we've got some videos on our YouTube channel. The controls are blocking stuff here. Let's see. Here we go. I've got a video here on whole building blower door testing where I talk a little bit more about setting up the building, because that's a big part of it too, especially if you get into these large commercial building tests. Scheduling is important. A lot of people choose to do this at night, especially if it's an occupied building. That way you're not bothered by other people, you have it to yourself. If it's new construction, you want to have the building to yourself as much as you can. The last thing you want, as I'm sure you're aware of, is people opening doors and walking around and stepping on your tubing. So the more control you have over that space, the better. So scheduling with the general contractor or the building engineer or whoever's in charge there is really important, and do it as far out as you can to get yourself a day to get in there and get done what you need to get done. And sometimes the building prep can take a good long time. So taping off exhaust fans, things such as that. Are you going to do that? Do you need to charge for that time? Are they going to have somebody do that? Are they clear on what they're supposed to be taping off and not? So those are really important conversations to have, and I go into that a little bit more in this video. This also has some footage from that really big test that I was telling you about with the 33 fans, so you can see how that's set up, how this kind of setup works on a large scale in a real world scenario. So I recommend looking at this if you want to get into this a little bit more. We're going to have a little bit of time here for questions at the end. But one thing that I wanted to mention too is I started a few weeks back Technical Tuesdays, if you follow us on social media, but I also put these on YouTube every Tuesday. But I do about a 1 to 3 minute talk or demonstration on a different aspect of testing, whether if it's blower door or duct testing or airflow measurement, using our manometers. So there's a new one every week. So if you want to kind of keep tabs on some different things to look out for, some new stuff that's coming out, you can follow us on social media or check back on our YouTube channel every Tuesday for these to get released. So that's just another way to keep you on your toes as far as testing tips go. Lee, do we have any questions in the box?
Yeah, quite a few actually.
Cool.
So, David said that it's interesting we have the 5,000 fan, the lower capacity fan as the primary on this test, and the higher fan or the higher capacity fan as the secondary. Do you just want to talk for a second about how that, which of those two series you pick doesn't necessarily matter when they're combined in a set like that?
Yeah, it really doesn't matter. I mean, they're going to work together no matter what. This is just how I happen to set it up. There's really no rhyme or reason to it. If you were to go and do this in the field, if you switched them up, you would get the same results. So that's really it.
Right,
Yeah.
with common control, the whatever gauge is number one is going to be looking at pressure in the building and adjusting its fan speed to get to target, and then that same speed command is going to be mirrored to the other fans. So it doesn't really matter which fan is primary there. Although it's better to have the DM32 and the newer series fan as your number one versus having like a 3000 or 2000 as your number one fan. It just goes a little smoother having the newer equipment as the primary. And then
Yeah, that's a good point.
Sam, there's a request to just go over briefly when you would use individual control versus common.
Yeah. So common control, anytime you're testing one single volume of space, like if you're doing a whole building test, that's when you're going to use common control because you want all of the fans running at the same rate. If you're going to do a neutralization test or a guarded test, a good example of this that we see the most common is multifamily buildings. So say you have a multifamily building that's full of apartments and you want to test a middle apartment, but you don't want to count leakage to the other units. So you would have 3 blower doors set up, but you only care about the leakage in the middle one, but you need to get all 3 to 50 pascals or whatever target pressure that you're using for, whether if you're doing a single point or a multi-point. That is the spot where you're going to use individual control because you don't want to include the flow on those outer 2 units. You just care about the single. You just want to make sure the other 2 get up to pressure. So that's an example of where you would use individual control. Anytime you're doing any sort of neutralization test like that, where you're getting several different adjacent volumes of space under the same pressure, but you only want to get leakage out of one.
Okay, perfect. And then how many minutes or seconds should you wait to take the last baseline reading? And I think that was a question on like recording duration, not necessarily time after your test.
Yeah, so I try to judge that on the wind conditions outside. If it's a windier day, I'll let my baseline run longer, maybe a minute instead of 20 seconds. It's really a judgment call on you. I mean, if it's a calm day and not much is happening, 20 seconds is usually okay. And you can take more than one baseline in FanTestic too. That's the nice thing. So that way you have more readings to collect to average together, and it'll give a more accurate representation of what's happening outside. I just did one today just for the sake of time. I'm sure you guys didn't want to sit here and watch 10 baselines get recorded. But yeah, you can do that. And the more you take, the more accurate it's going to be. But I treat the initial and the final the same way. Yeah, just depending on the conditions outside.
Right. And then making sure you comply with whatever standard requirements there are. Usually like 20 seconds is good as like a minimum that would meet almost all standard requirements.
Yeah, that's what the default is in the software.
Robert was asking, what about a USACE test? Are the methods and parameters the same?
Yeah, so for a lot of standards, if we're doing like the Army Corps of Engineers, we'll actually test in both directions and take an average of the 2. So we're pressurizing the space. And so I would run that test. And then I would run the test again with the fans in the opposite direction and then take the average across. So those get a little bit more involved because they want to see exactly how that building is leaking under more than one scenario. So yeah, that's a great question.
All right. And let's see, in the case of a taller building.
I'm gonna add to that one a little bit too. You can have multiple tests for a certain property. So after I would finish that test, I would start a new one and then average those results at the end there. So yeah.
Okay, cool. Let's see. So in a case of a taller building, like 20 stories, where would be the ideal location to set the fans up?
Yeah. So if you're going to do a whole building, for 20 stories, that's pretty big. What I would usually do there is have some fans set up at the bottom and then some set up at the top. And then you would have your test station where you would have your laptop set up and everything meeting probably somewhere in the middle, one of the middle floors. That way you have the shortest path possible for both sets of fans to come in. And another important thing to note too is referencing floors in between. So usually what you'll have is one of the Bluetooth on the blue port of the DM32, you'll have a tube coming off of that from different gauges to go reference different floors just to make sure that entire building is hitting that one universal target pressure. But as we get into taller buildings, it usually helps to get some fans up top and on the bottom. So it's kind of pulling from both ends to make sure that it's getting that pressure all the way through the building.
Yeah, and that's kind of a large topic and something that should really be looked at individual, like on an individual basis per the building you're testing. And it's really determines like how much opening area you have into the stairwell or whatever you're using as your plenum to distribute pressure. When that becomes a restriction, then you run into problems. So like Sam was saying, if you put fans at a couple different locations, you can increase the amount of air you're getting into that plenum, into that stairwell. And that definitely helps. But it is something that should be looked at, per building.
Usually for really tall buildings like that, we usually see it tested in sections. So there'll be some samples tested. So you'll take the bottom floor, you'll test the top floor, and maybe, you know, 2 or 3 floors in between. Uh, that way you don't have to have a huge amount of fans to do it, and just see if they're all behaving the same way. So that's another way to go about that.
Someone was asking if we could push the graph button on the test file you have open.
Yep. That's going to be under. So what this basically does is it shows your slope, to show how that building is leaking. And you'll find that number here, slope. So this one's actually a lot lower than what you would see. This slope number is usually going to fall somewhere between 0.5 and 1.0. And it's referring to this regression line right here. So this was our, this is our
Sam,
test.
did you mean to share your screen?
Oh, yeah, sorry about that. Let me, it's thinking about it. Here we go. Come on. There we go. So I'll close this out. Back under where we have all our test data here that was showing up, there's a show graphs button. And so you can pull this up. And so this was if you look across the x-axis here, this is the building pressure where we started off at 60 pascals and worked our way down to 10. And these were our flows on the y-axis. And you see this regression line right here, and that's our slope. And so when we do a multi-point test, one of the benefits of doing a multi-point test is being able to calculate that slope. And that's where you see this number here at this 0.565. This is a little lower than what you would see in most buildings in the field, because I have some big holes opened up in this chamber, so I can make it kind of behave like a larger building. But it's usually going to fall somewhere between 0.5 and 1.0. And the closer it is to 0.5, that means that you're going to have some big open holes somewhere. If it's closer to 1.0, that means it's just going to be a whole bunch of tiny holes. So that's something that number can tell us. And that's just how it looks when it's graphed out like that. I know it's been mentioned on some webinars we did last year, so it's kind of public knowledge, so I'll just go ahead and mention it here too. There's a new version of this software that's in the works that'll be coming out at some point whenever we're ready to release it, where it'll have this graph that's a little bit more involved and easier to access. And you'll be able to actually, if you're doing an individual control test that involves multiple fans for different zones, you'll be able to group fans a lot easier, and there'll be some different changes to that. But we'll still be using this version of the software for a little while longer, and before we switch over to that new one. But yeah, since we've already mentioned it in previous webinars before, that's just something to keep an eye out for. But yeah, if you just wanted to see, if you wanted to add that to a report and explain what this means, and explain what that slope number means as far as how the building is leaking, yeah, you can definitely add that in.
Kind of on that same topic, and probably worth mentioning, and you may have, I might have missed it, but the individual error percentages per flow point, and looking at those to see what should be retaken.
Uh,
So right above the calculate button on that row,
oh yeah,
just
yeah,
above the
yeah.
button, when you take an auto test, you could use that row to see which of your points is the outlier, and then use semi-auto to retake that point to improve your overall accuracy.
Yeah, that's a good point.
Let me see. There was a Jason was asking. He said recently tested a block of townhouses mid construction and found that the unit with the primary controller could hit target pressure, but the remaining linked fans could not hit pressure. Any idea why that happened? Uh, Jason, probably due to the control setting, that common versus individual control. Sam, could you show where that is in the menu really quick? If that
Yeah,
was set incorrectly, it may have been that the primary gauge was at pressure, but the secondary gauges were trying to run at a different speed. If it was all one zone. Actually, I'm sorry, I've got that backwards. If you're doing townhouses and you had the fans in different units, you'd want it set to individual and not common. If you had it
exactly.
set
That
to
was
common, they're all going to run the same speed. So my apologies, got turned around.
yeah. So I'll do that again. So if you hit the settings tab and hit advanced under this basics, you'll see gauge control, common or individual. That's where you would change that. So I would look at that in the software because yeah, if you're doing guarded tests or neutralization tests on those townhomes, then that's when you would want to switch it over to individual. Yeah,
There's
that,
a question.
sorry, yeah,
Yeah.
that makes the most sense.
There's a question about if we're planning on adding ASTM 3158 to the standards list, and it has been requested. They're looking at adding it in, just not sure on ETA. So it is on the agenda though.
Yep.
And finally, how stable is the network accuracy with data, wireless versus wired, and anything to consider with the wireless connection side?
I always, when you get into multi-fan tests, I always recommend doing it wired. There's just less chance of something going wrong.
Yep, definitely
That
agree. It's
that's my experience.
depending on how much you have between the gauges in the computer and the fact that the DM32 has an internal antenna versus most routers having like an external antenna or being able to produce a stronger signal. It's just a lot easier to have or a lot more stable to have a wired connection.
Yep. And use the yeah, as you're adding more gauges. I mean, I've used the USB connection in the field with 2 gauges. I don't think I've ever done it with any more than that, and it's worked just fine. But our software development team recommends that in order for everything to go smoothly, at the highest chance of that, use the Ethernet connection with a router.
What if we need to get the overall air tightness for a townhome block, say 5 units at once? Common control seems to make sense there. Was a question we just got.
Yeah, I mean, if you're testing all those at once and you just need one leakage number for that entire block, then yeah, you would have a fan set up in each unit and then just run common control.
Well, it'd be common control if it's all one zone and they're interconnected. If they have individual doorways and they're not part of a common zone, if each fan was in a separate unit in a block, that would be individual. If it was
Yeah,
one
you're right.
common zone, it would be common.
You're right. Yeah, if it's an apartment building where you get to it from the inside, like if there's a corridor, then yeah, you would just have all those doors opened up and run common. But yeah, if they're not interconnected that way, then yeah, you want to have if you're using common control, you just want to make sure that there's an air pathway connecting all of those units together, which in townhouses you usually don't have that.
Awesome. Okay, I think we got through all the questions here.
Cool. Well, that gets us pretty close to our hour here. Appreciate everybody logging in. And if you want to reach out to us, you can shoot me an email. It's just sam@retrotec.com. If you ever get out and have some issues in the field, you can reach out to support@retrotec.com. You'll get either Lee or Tim. And we're always here and happy to help you out. Feel free to drop us an email too if you have any topics that you would like covered, or if you would like to see a specific topic covered in one of our Technical Tuesday videos. Let me know, and we can put that on the list to get out. And other than that, if there's no other questions, then we'll go ahead and wrap this up. Thanks again for logging in with us and spending this hour with us, and we'll see you back here next time. Lee, thanks for your help.
Yeah, thank you.
Yep.
See you, everyone.